Okay, so good morning, all of you. So I think you will be well and studying well at home. Okay, so we'll start the chapter number 20, that is called as the isothermal and adiabatic processes. Okay, isothermal and adiabatic processes. Okay, chapter number 20. Okay, so it is called as the isothermal and adiabatic processes. What is isothermal process and what is adiabatic process? We will discuss. So first, we'll discuss about the what is isothermal process. Isothermal process means if the process is carried out at a constant temperature. Okay, that means if the temperature of the what if the process particular process is carried out at a constant temperature, then this particular process is called as the isothermal process. Then particular process is called as the isothermal process, or you can call that when the system undergoes a physical change. When a system undergoes a physical change under the condition that the temperature of the system remain constant. If the temperature of the system remain constant at that particular condition is called as that process is called as the isothermal process. Okay, so in this particular process what will happen, the necessary condition for the isothermal process is the material which we are using, that should be perfectly conducting material, okay. So whatever the what material that will use in the particular isothermal process, that should be perfectly conducting material, okay. And in this particular process, isothermal process, temperature will be keep the constant, will keep the temperature as constant, okay. So if the temperature will be constant, then it will also obeys the Boyle's law means what? Boyle's law is PV equal to constant, okay. So that means this particular isothermal process obeys the Boyle's law also, okay. So Boyle's law means the pressure of a given uh, the pressure is inversely proportional to the volume at constant temperature. At constant temperature, the pressure of a given mass of a gas is inversely proportional to the volume. Okay, so this is called as the Boyle's law. And if you make the curve, that means isothermal curve. That curve of the isothermal process is called the isothermal curve. Okay. Isothermal curve. Okay. Uh, what does the curve tells about? The curve says that at a different temperature, this is the temperature T1 at the temperature T2, okay. So that means this is the this is the graph between pressure, okay, and this is the volume, okay. So pressure and volume, there's a graph between pressure and volume at different temperature. At different temperature, you just take the pressure in between, the what is the variation or what is the graph between the pressure and volume at a different temperature T1 and T2, okay. So if you can write also, if PV equal to constant, if PV equal to constant for the isothermal process, if PV equal to constant, then we can write, if you just take the derivative from the both sides, if you just take derivative, then what will happen? P into dV plus V into dP equal to constant derivative will be 0. Yes or no? So if you just take the derivative means it is a chain rule will be applied here. So PV it is given. So that means you have to take the one derivative and another will be keeps constant. So P dV plus V dP will be equal to 0. Okay. So then also you can write it dP upon dV. dP upon dV. In the case of isothermal process, it will be what? Minus P upon V. Also you can write it from this equation. You can write dP upon dV equal to minus P upon V for the isothermal process. For the isothermal process, dP upon dV, okay, it will be minus P upon V. This is for the isothermal process. Then comes to adiabatic process. Then comes to what? Adiabatic process. What is the equation for the adiabatic process? And when a system undergoes a change under the condition that no exchange of heat takes place between the system and the surrounding, okay. When the system undergoes a change under the condition that no exchange of heat will be takes place from the in between the system and surrounding, if there is no heat that can be exchanged, that particular what process is called as the adiabatic process. That particular process is called as what? Adiabatic process. Okay. So in this particular process, uh, what we are just taking, that means in the particular practical case, the adiabatic process, hence a perfect adiabatic process is impossible in the practically. Perfectly adiabatic process is impossible, because when the process takes place very rapidly, okay, adiabatic process occurs very rapidly, so that the heat does not find time to flow in or flow out. Okay, so practically the perfectly adiabatic process is but impossible. Okay, so for the perfectly ideal gas equation, for a ideal gas equation, there are some relation between the pressure and the volume. That is the, for the adiabatic process it will obey some laws. That means what are the law between pressure and volume, that is called as the uh, what are the relation between pressure and volume. Relation tells that PV to the power gamma equal to constant. PV to the power gamma equal to constant. This is the but equation. This is the relation between the pressure and volume in the isothermal process. In the isothermal process, what is the relation? The PV to the power gamma equal to constant. Okay. And what is the relation between temperature and volume? The TV to the power gamma minus 1 equal to constant. Okay, you have to keep what remember this particular relation. TV to the power gamma minus 1 equal to constant. And third one is the in between the pressure and temperature. What is the relation? T to the power gamma divided by T to the power gamma divided by P to the power gamma minus 1 equal to constant. Okay, so this is the other three relations between the pressure and volume for the adiabatic process. If you're just taking the ideal gas, if you are taking the ideal gas, then for the adiabatic process, the PV to the power gamma equal to constant, TV to the power gamma minus 1 equal to constant. Third one, the T to the power gamma divided by P to the power gamma minus 1 equal to also constant. Okay, so these are the three relations are there. Three relations are there. Okay, on the basis of the particular relation, the particular for the adiabatic process, for the adiabatic process, the relation between pressure and volume will be P V to the power gamma equal to constant, T V to the power gamma minus 1 equal to also constant. And gamma means what? What is gamma? Gamma equal to gamma. I will study gamma. Gamma means it is the what? It is a constant factor, but it is called as the ratio between the Cp by Cv. Cp means we will study about the Cp and Cv later. But first of all, if it is given the what in this particular equation, I'm just telling. So gamma equal to Cp upon Cv. Cp means specific heat at constant pressure divided by specific heat at constant volume. Okay, so gamma means it is a proportionality constant, but it is what is the ratio? It is the ratio between the specific heat at constant pressure divided by specific heat at constant volume. Okay, so it is the gamma. And these are the three equations are there. And R means R means it is the proportionality constant, or it's called the gas constant also. It is called as the what ideal gas constant, or it is the gas constant. Gas constant. Okay, so these are the constants are there. Then comes to adiabatic curve. What are the curves of the adiabatic curves? If you the graph drawn between the pressure and the volume of the given mass of the gas undergoes the adiabatic change is called as the adiabatic curve. Okay, if you just make the graph between the pressure and the volume, okay, of a given mass of a gas, that curve is called as the adiabatic curve. For the particular curve, the same thing will be happen. That means dp upon dv, dp upon dv for the adiabatic process. For the adiabatic process, it will be also equal to minus gamma p upon v, minus gamma p upon v. That means dp upon dv equal to minus gamma dp upon v. Okay, and for the for the isothermal or adiabatic, if you compare the slope of isothermal and adiabatic process, the slope between the isothermal and adiabatic process will be gamma. That means if you just find out dp upon dv for the adiabatic, and you just define already we have find out the dp upon dv for the isothermal, then what will the happen? dp upon dv for the adiabatic process divided by dV upon dV for the isothermal process. It will be adiabatic. For the adiabatic it will be gamma P upon V divided by minus P upon V. So we just cancel from the negative sign, also cancel. What is remaining? Only gamma is remaining. Okay, so so it is the what? It is the ratio gamma. You can call as due to the we can compare the what slope of isothermal process as well as the adiabatic process. Okay, adiabatic process graph as well as the isothermal process graph. Okay, and the next chapter, that means chapter number 2021, I think it's chapter number 21. Okay, I will send the video. I will send the video of chapter number 21. Okay, so you will see, just to see the video. If you have any doubt you can ask me. Okay, next come to work done by an ideal gas in the isothermal expansion. Okay, due to less time actually, so we will just send the video. Some chapters we just send the video. Okay, I have just already make the video, so just to see the video. And also numerical section, theoretical section, all the things sections are derived in that particular video. You just to see the video. If you have any doubt you just ask me. Okay, after this, just to see the video. Okay, so then comes to work done. How can you find out the work done in an isothermal process? Work done in an isothermal process. Isothermal process means if the temperature remain constant. Temperature remain constant. That particular process is called as the isothermal process. Okay, the temperature throughout the process, the temperature remain constant. That particular process is called as the isothermal process. Okay, so how can you find out the work done? Work done equal to, you already know that formula. Work done equal to PDV. What is the formula of work done? Work done equal to PDV from V1 to V2. If the limit is varying from V1 to V2, so work done will be PDV. Is or no? So for the work for the isothermal process, means if the temperature throughout the process remain constant for isothermal process, then how can you find out the work done through isothermal process? Work done equal to we already know that the formula. Work done equal to PDV. How it will be PDV? So W equal to what? Force into displacement. Yes or no? So force equal to pressure into area into displacement. Yes or no? So pressure into area into displacement, it will be dV. Yes or no? So W equal to PDV. So that we have written here. The W equal to PDV from V1 to V2. V1 means from volume V1 to volume V2. Okay. Then we have already really one relation was there. That means PV to the power gamma equal to constant. This is the for the adiabatic process. This relation is was there. PV to the power gamma equal to constant. Yes or no? So we can write PV. We already know that the PV equal to nRT. Yes or no? From the for the ideal gas equation, PV equal to nRT or mu RT also we can take. Yes or no? That means for the ideal gas equation from the chemistry also you have learned about PV equal to nRT. So PV equal to mu into RT. So mu, that means if you want to find out the P means P equal to mu RT upon V upon V. Is or no? So you just put in place of P, you just put mu RT upon V into dV from V1 to V2. Is or no? So mu RT is a constant. Just to take it outside. Okay. As it is isothermal, so temperature will remain constant. R will be also, R is a gas constant. Mu is the number of moles. Mu is the what? Number of moles. Okay. So mu RT will be constant. So what will the remaining part? dV upon V from where? V1 to V2. Yes or no? So mu RT dV upon V means it is the ln V. The one formula is there. That means if you just find out the derivative integration, that means integration of dV upon V, it will be ln V. So it will be ln V from where? From V1 to V2. Yes or no? So mu RT, mu RT ln V2 ln V2 minus ln V1. Yes or no? So you just put here upper limit and the lower limit. So from the upper limit, that is V2, and ln V2 minus ln V1. Is or no? So these are the W equal to PDV. I'm just again telling W equal to PDV. PDV, from the where we are getting the PDV, W equal to F into dx and PA into dx. So W equal to P into A into dx, that will be dV. Okay. So W equal to PDV. Okay. So you just take the PDV from varying from V1 to V2. Then what will happen? You know that PV equal to nRT or mu RT. PV equal to what? nRT or mu RT. So P equal to mu RT upon V. P equal to what? Mu RT upon V. Okay. So in place of P, you can write mu RT upon V, V1 to V2. Then mu RT equal to dV upon V. That means mu RT. All the things are three things are constant. You just take it outside. Mu RT you just take outside. What is the remaining part? dV upon V. Okay. So mu RT ln V1 plus V2, mu RT ln V2 minus V1. Okay. So mu RT ln V2 by V1. This is the formula for the what? Work done in an isothermal process. In the isothermal process is the formula, that means mu RT log E V2 by V1. Okay. So you can also write as we know that in the term of pressure also you can write so mu RT log P1 minus P1. As you know that P is inversely proportional to V. Yes or no? So P is inversely proportional to V. So that means PV equal to constant. Yes or no? That means P1 V1 equal to P2 V2. Yes or no? So in place of that, you can write also what V1 by V2. That means P1 by P2 equal to what? V2 upon V1. Yes or no? So in place of V2 upon V1, in place of ln V2 by V1, we can write also mu RT ln. Okay. So ln also you can write log E also. Log E and ln both are same. Okay. Log E P1 minus P2. P1 minus P2 also you can write. Okay. P1 minus P2 or P1 divided by P2 also. Ln V2 by V1, or also you can write here mu RT ln V2 by V1 also you can write. Also you can negative. This also you can write. This also you can write. Okay. So if you just if you want to change the ln into log. Okay. If you just want to change the base, that means here the base is log E. Okay. If you want to change it log 10, then you have to multiply 2.303. Okay. You have to multiply what? 2.303. Then we'll discuss about the what is the work done in the adiabatic expansion. This is the work done in the isothermal expansion. Okay. Then comes to what is the work done in an adiabatic expansion. In the adiabatic expansion, how the work, we can find out the work done. Work done in adiabatic expansion. In the adiabatic expansion, how can you find out the work done? Okay. In the adiabatic expansion, we know that the heat, whatever the heat that is given to a system, that will remain constant. Yes or no? So whatever the heat that is given to a system, that will be remain constant in the particular adiabatic expansion. Yes or no? So here, what is the relation between the P and V? PV to the power gamma equal to constant. Gamma is called as what? Gamma equal to Cp upon Cv. Okay. So this relation between the pressure and the volume for the adiabatic process will be PV to the power gamma equal to constant. Okay. So W, we know that the work done equal to PDV. Yes or no? From where? From V1 to V2. From V1 to V2, PDV. Yes or no? So in place of P, we can write as the PV to the power gamma equal to constant. PV, just see that the PV to the power gamma equal to constant. Yes or no? constant. So how can you find out the p? P equal to k by v to the power gamma minus v to the power gamma, yes or no? Or you can write k into v to the power minus gamma also, yes or no? K v to the power minus gamma, yes or no? So k v to the power minus gamma dv, integration from v1 to v2, yes or no? So k is a constant, k is a constant, and k can be taken outside. So minus gamma derivative integration is just to find out what will the value, minus v to the power minus gamma plus 1 divided by minus gamma plus 1 from v1 to v2. Yes or no? So we can write a 1 by gamma minus 1, 1 by gamma minus 1. Okay. So v2 to the power gamma minus 1, okay, v2 to the power 1 minus gamma, okay, so minus v1 to the power 1 minus gamma also you can write, okay. So v2 to the power 1 minus gamma divided by 1 by 1 minus gamma, 1 minus gamma plus 1, that can be written as 1 minus gamma, that will be v2 to the power 1 minus gamma minus v1 to the power 1 minus gamma, okay. And you already know that one formula, that means in place of what v2 also you can write, that means what in place of v2 we can write this formula also. We know that p1 v1, uh, as we know that pv equal to constant, pv equal to constant or k, it is called as the k. So you can write a p1 v1 equal to constant, as well as p2 v2 equal to constant also, okay. So as the p1 v1 equal to p2 v2 equal to constant, so k, in place of k we can write we can write 1 minus gamma. In place of that we can write what, k divided by v1 to the power gamma minus 1, gamma minus 1 minus k by v2 to the power gamma minus 1 also you can write, okay. Then just see that as we know that in place of p1 v1 equal to constant and p2 v2 equal to constant, so in place of that we can write k by v1 to the power gamma minus 1. That means what is the value, pv to the power gamma equal to constant. So that means p1 v1 to the power gamma equal to constant, is or no? So we can write p1 equal to what, k by v1 to the power gamma minus gamma, is or no? So that means we can write a k by v1 to the power gamma. So here it is given k by v gamma minus 1. So in place of k we can write p1 v1 also. So just write down and w equal to 1 by 1 minus gamma. Here k it is given, so k means what, p1 v1, we can write a p1 v1, is or no? P1 v1 to the power gamma divided by v1 to the power gamma minus 1, okay, minus k, in place of k we can write p2 v2 to the power gamma, okay, divided by v2 to the power gamma minus 1, okay. So just divide these things, you will get what will get, w equal to 1 by gamma minus 1, 1 by gamma minus 1, okay, it will be gamma minus 1 also, because we have taken the LCM, so we just put it gamma minus 1, okay. So 1 by 1 minus gamma minus 1, p1 v1, p1 v1 minus the p2 v2, okay. So w equal to 1 by gamma minus 1 p1 v1 minus p2 v2, okay. And if you just write down this particular formula, this is also one type of one formula, and another formula also you can derive from this particular equation. What is the next formula? Next formula is that we have already know that P1, you know that PV equal to nRT or mu RT also, is or no? PV equal to nRT, is or no? So that means P1 V1. If you are writing P1 V1 equal to mu RT1, mu R T1, yes or no? And P2 V2, similarly P2 V2 will be how much? P2 mu R T2, because it is the ideal gas equation, PV equal to mu RT. Okay, so we can write P1 V1 equal to mu R T1, because if you are taking the one, that means P1 V1 equal to mu R T1, and P2 V2 will be mu R T2, yes or no? So you just put it here, then what will happen? W equal to, W will be mu R, mu R, okay, mu R, uh, T1 mu R divided by gamma minus 1, gamma minus 1, okay, T1 minus T2, T1 minus T2, just put it here, then after we will get what? W equal to mu R divided by gamma minus 1, T1 minus T2, okay. So just also you can write if mu equal to 1 for the 1 mole of gas, if you're just taking the mu equal to 1, if you're just taking mu equal to, if mu equal to 1, then what will happen? W equal to R divided by gamma minus 1, T1 minus T2, okay. So this is the what relation between what work done through a adiabatic process, okay. So next class we will discuss about the what comparison between the adiabatic process and isothermal process, then after we will discuss the specific heat. Okay, thank you so much.